Question 15. Two thin dielectric slabs of dielectric constants K1 and K2. K1 less than K2 are inserted between plates of a parallel plate capacitor as shown in the figure. The variation of electric field E between the plates with distance D as measured from plate P is correctly shown by. This is a diagram given. These are the graphs. 4 options. CBSE AIPMT 2014. We go into the solution. See, two thin dielectric slabs of dielectric constants K1 and K2. So this is one dielectric slab, okay. This is another dielectric slab. Here and all free space. Here you have free space. Free space. Here also free space. Here also free space. So Fs for free space. Okay. Rather than writing fully, I just write Fs for free space. These two dielectrics. Okay. Now, how the electric field varies as you move from plate P this side. How electric field varies. Suppose there are no dielectrics. If there is no dielectric, if there is no dielectric, if no dielectric, no variation in electric field. It's uniform, we know that. But there is a dielectric. Dielectrics will undergo what is known as dielectric polarisation. So, electric field will decrease. Electric field inside a dielectric, inside any dielectric is less compared to outside, due to what is known as dielectric polarization. Dielectric polarization. So, if you want to know about dielectric polarization, you can watch my video on dielectrics. Okay. So now, because it is a NEET practice question, I am not going into the derivations part of it. So dielectric polarization will make the electric field inside the dielectric less. By what factor? See, suppose here the electric field is, say, E0. If you keep a dielectric here, the electric field is E, the dielectric is subjected to the electric field. Then electric field here will be less by a factor equal to dielectric constant of the medium. That is, inside E is equal to, this is E is equal to, inside E is equal to E0 by K, outside E0, here also E0. Okay. Inside it will be less. I am not showing complete picture of dielectric polarization. Okay. Field inside will be less. I am not even showing induced charges and all, not necessary. What you have to understand, inside a dielectric, field will be less compared to the field outside. By what factor? By a factor K. What is K? Dielectric constant of the medium. Now come to this. So here field will be less. Less electric field. So we start analyzing the graphs. Here the value is, say, E, some value, okay, when D is 0. So that's the field here, beginning. Then the field increases as you go to the right side. So It has to decrease, but it shows as if the field is increasing, so this is not possible. Now come to this. Of course, here the field decreases as you cross this region, first region. Okay, up to this fine. Then again it increases. It should not increase. Field in region 1, I consider this as region 2, this as region 3, this is region 4, this is region 5. Field in region 1 will be more than field in region 2. Or E2, field in region 2 is less than E1. Field in region 1. E1 is field in region. So less, that's fine. But again, field in region 1 will be same as field in region 3 because they are free space region. That we know. E1 is also equal to E3 is also equal to E5 because they are all free space regions. E1, E3, E5 free space, they are all equal. But here you see it is coming equal, no problem, corresponding to E3. So E1, E2, E3. E3 and E1 equal. E1, E3 equal. E2 less. Fine. But here E1, E2, E3, this is E4. It shows more. But actually this E4 is the field inside the dielectric. So E4 should be less than E3. It can't be more. So this is also ruled out. That is, this region should be less. We'll see by what amount, but just less, but it is showing it to be more. So this is not possible. Coming to this. E1, E2, E3, fine. E4, this is E4. E4 should be less than E3. Right? E1, E2, E3. This is E3. This region is E3. E3, E4. Right? E4 should be less than E3. That is correct. But what is the case? E4 should be E3 by K2. Again here, this is E2, no E2. E2, field at 1, field at 3 are equal. Remember that. Just for explanation sake, I have numbered them. Otherwise, you should know because they are free space values. 1, 3, 5 free space values. 2 and 4 dielectric, field inside the dielectric. They represent field inside the dielectric. These are all regions. Region 1, free space region. Region 3, region 5, free space regions. Region 2, dielectric region, inside dielectric. Region 4, inside dielectric. But K2 is, you see the question, K2 is greater than K1 or K1 less than K2. So E2 is E1 or E3. E1 by here dielectric constant K1. You can even write this as E3 by K1 because E1 is equal to E3. Now compare this and this. Okay, compare now E2 and E4. Now that we have K2 greater than K1, given K2 greater than K1, so E4 according to this K2 should be greater, so E4 should be less than. So comparing these two and using K2 greater than K1, E4 less than E2. This is E4. this value, that is E4. This value is E2. See, E2 less than, sorry, E4 less than E2. So this is correct. Here and all you see electric field becomes 0. Here 0, here 0. Only inside a metal electric field will be 0. So out of the 4 representations as a graphs, option C is correct. Okay.